I'm Mikhail Novikov. I'm going to talk to you about GraphQL on client side, and in particular GraphQL client-side caches. And I'll talk to you about why would you use a client-side cache in your application, and why would you use a GraphQL client-side cache in your application too. And then I'll tell you how you build the client-side caches and how they're usually built with GraphQL. And then I'll talk to you about what next for GraphQL client-side caches and probably like client-side caches in general. So I like cats. This is my cats that I leave in my apartment. And yeah, this text is unreadable, but my cats are more important, so I'm going to prioritize my cats. So I'm co-founder of a startup and now a consulting company called Reindex. We were the first GraphQL startup, like in the whole world. We did GraphQL before it was cool. We did GraphQL before it was released. We did GraphQL by reverse engineering Facebook applications to see how GraphQL works. After that, we failed. Our startup didn't work out. And I worked in different projects. I built Apollo Launchpad, which is like a code sandbox for GraphQL APIs. I contributed a lot to GraphQL tools, like GraphQL delegation, GraphQL schema stitching, GraphQL transforms. Those are all tools for building GraphQL gateways, and I implemented them. So yeah, I'm all the way into GraphQL. And yeah, I'm going to talk about client-side caches. And I want to kind of clarify because the terminology is so complicated here. Sometimes we call it GraphQL client or API client. Sometimes we call it client state management. We call it Redux a lot, too much. Some other people call it MobileX, Flux, Ember Data. In GraphQL world, it's mostly Apollo client, Relay, and there's a new cool kid on the block called Urkel. And one thing about it is that I'm going to focus on actual API interactions in this talk and caching the API results. So there's a huge amount of client-side management that doesn't actually relate to the API. Like in Redux, you probably have like all the UI interactions coded inside the Redux, but I only am focusing on actual data that comes from the server and how it is reused. So there's like a lot more to it, but the cache is the focus of this talk. So why do you need a cache in your application? So when we moved from request-response application to single-page application, we did it to make them fast. And if you have to do HTTP request every time you transition from one view to another, it's kind of opposite of fast, because you still have to do it the same request. And your code is probably more complicated because you render it all in JavaScript. So like, what's the point of SPA if you don't actually cache the results? So you need a cache. So that you don't have to query more than you need. And like a perfect cache library, what it means. And well, first of all, it means that you fetch stuff only once. If you have two views in your application that both use the same data and both have to query the same resource, when you transition from those views or back to some view, you don't want to make another request. You don't want to refetch the same data you have again. Second one is that you not just want to reuse the data and to keep the data that's in one context or one service, but also in others. For example, you might have a view that has a list of items, and you already fetched the data for all the items in this list. And now you want to transition to a single item. And you don't want to fetch the single item if you already have this data from a list. So this is what reusing different context means. Then you also want your cache to be able to know if the data you've received is full, complete, because especially in REST and in GraphQL too, because you use queries in GraphQL, you might get the data that's partial. And you might get the data that's returned inline in your resources. Like when you're getting a picture, you might get like list of comments, and you might not always get the whole data you need to display some special comment view. So the cache should be able to tell you if you have the full data. And ideally, the cache should be able to tell you what data you have. The next step is updating and invalidating applications. After you change something, and after you call your server to update something or delete something, your cache should be correspondingly. And it might be just simple invalidation. You know, a user logs out, you invalidate the whole cache. That's usually the strategy. But it might be only selective invalidation, selective updates. You update an object, you basically just write a new version of this object to the cache. And the last and most important for me is that you don't want to write all this code manually every time for every single page application you're building. Because often it's the case. Like our APIs are also special Snowflake, and our application also become really special because we have to build all those caching layers from scratch manually. And I wish we didn't have to do it. Sorry. So yeah, now that we've figured out what the perfect cache is, let's talk about how we usually implement caches in our applications. So the simplest way to do the caching is what I call resource caching. And what it means is that we implement a layer inside our application where every time we call our backend, like for example, the URL by which we call our backend is going to be our cache key. So if we have a list of pictures, then our cache key is going to be the URL for pictures. If we are fetching a single pictures, it's going to be picture/5. And if we are fetching like your current user, it's going to be /me. So this is really simple. Like the cache layer basically just needs to be, if you have this data, return it. If you don't, fetch this URL. It's extremely simple. But yeah, and you only fetch once because all the views that have use the same service, they're not going to be refetched. But it's not possible to use in context because there's no way for your cache to know that when you're moving, for example, from a list, that the ID service for pictures is actually the same service, and that you can probably reuse the data in there. And you can invalidate stuff manually, and this two hammers means that you have to write code to do it by just invalidating the services that are affected by mutations. And yeah, it doesn't know anything about data completeness, but it's super simple. So in the GraphQL world, we have URQL. And URQL basically is GraphQL resource caching. And instead of URLs, it uses GraphQL queries. It basically takes the hash of your GraphQL queries in your variables, and then it uses that as your cache key. And it's extremely simple because of that. You don't need to do any other code. You just have a query, you connect it to a component, and then you have data fetched. And you can invalidate those queries inside your mutation by just listing the queries you want to invalidate. Ooh. Yeah, so while resource caching is nice and simple, it doesn't solve all the problems that we want the perfect cache to solve. So then we move to object caching. And object caching is when we get the data from a resource, and we somehow convert it to an individual objects that are inside this response. And then we store this individual object in cache, usually by ID. So you will have cache keys like picture list, fifth picture, or user when you're doing that. And if you get a response like that, where you have a list of pictures, you have an author, you have a comments, what you will get at the end in your cache, something like that, where you flatten or normalize their response, and you cache everything by their type name and ID. And usually you do it manually. You yourself know what your API responds. You yourself write this code. So every time you need to implement a storage or a normalization for a different endpoint or for a different API, you'll have to do it again. Because there's no way for cache to know that author is actually a user object, or that comments return a list of comments. So yeah, with object caching, you can fetch only once, because all the views that depend on some objects by ID will not get refetched if they're already there. And you can reuse it in context, because you're no longer bound to the services that are inside your API. But again, the list view can request a picture by ID, and the picture list request already populated the cache with pictures by ID. And you have to manually update stuff on mutations. Basically, your mutations might say, OK, I'm getting this object. I know it's a new version of the object I want to update, so I'm updating it. Or I know that this is a delete operation, so I'm going to delete it. And you can manually handle data completeness. It honestly gets super hairy. I've tried to do it, and it gets really complicated because you have to have different caches for full object and partial objects. And yeah, don't do it. It's really complicated. And basically, you have to write all this code yourself. every time you build a single-page application and you want to do your manual object caching, you would write the normalization logic yourself, and then invalidation logic yourself, and then updating logic yourself, and all the other logic yourself. It's lots of code. But maybe it can be a bit simpler. What if every time we get the data, we also knew what the type of every object is? So our previous response is almost the same, but you see we have this magical __ type name, which is the name of this type. So now, instead of writing the code manually, we can basically just traverse. Every time we get the data, we traverse it. Every time we encounter __ type name, and if it has an ID, we know that we can store it in this particular store for this type name. And yeah. So now we come to GraphQL, because Apollo client does exactly that. So in GraphQL, every time you fetch something, you can always specify this __ type name. It's this magical introspection field in GraphQL that lets you get the type name of this object. So now you just add this to a query, and Apollo client can extract this and store it by ID inside your cache. So your IDs will look like that. The important thing here is that even though you can extract, for example, the list of pictures from here or an author, you also need to have a concept of a route, because all your queries in GraphQL start with something. So you also need to cache where your query begins. And here we know that query begins with pictures. So we will also have this kind of root picture storage, which would be the the beginning of our cache. And what basically happens behind the scenes when you connect your component to Apollo client is that you use this route, you use this query as a cache key. And then Apollo works to resolve all this stuff internally. There are some problems with reusing this in context because of that. Because if you think about it, now we are mixing this resource caching, where we're caching by a resource name or by a query, and the ID caching. So when you have situations where you have like a root cache here is pictures, and you've just returned the list of pictures. And here the cache is picture by ID, and there's no way for Apollo to automatically know that this picture by ID is actually something that returns picture by ID. We can, of course, parse and have some really weird logic to know it, but it might just be something that is called picture by ID and takes ID, but it might be totally different. So this thing won't reuse the picture automatically. In order for you to write the code that reuses your data in context, you have to manually query the cache in Apollo. So again, manual work. And one cool thing about Apollo is also that it knows how to, because we have like this GraphQL query, a GraphQL query is basically all the info you need about the completeness. Because whenever you store something in a cache, alongside the data, you can also store a fragment, which basically is a representation of what kind of data you have. So whenever you're trying to read some data from the cache, the Apollo can check if this data was actually retrieved. And if not all the data you need is retrieved, it can either requery or throw an error, so you can know how to handle it if you don't have a complete data. So Apollo, you fetch only once, because whenever you transition to a view that uses the same query or a similar query that's compatible with what you already have, it won't fetch it again. You can reuse stuff in context, but it requires manual work. So it's kind of a downgrade from object caching, where you had it out of the box. Apollo updates stuff on mutation. Whenever you get the object in a query, and every time you get an object in any query, be it mutation or a normal query, it will always update the cache with this object. And yeah, it handles data completions. And when you only handle the stuff that it supports well, you don't have to write much code. Of course, as soon as you step out of the supported feature set, you will have to write more code. So yeah, but maybe we don't have to stop here. Maybe Apollo in some way can know how to associate a picture by ID with some particular root field. So yeah, what if we knew more about our API? What if we had some restrictions placed on our API by our cache that would let the cache know how to do those things automatically? So meet relay, the next GraphQL client-side cache. This one is from Facebook. And this one was the first, but Apollo client is much more popular nowadays. So one thing that Relay has is the special concept of relay-compatible GraphQL. And the most important part of this relay-compatible GraphQL class is so-called node interface. So what is a node interface? Basically, every object that you want to be cached by ID in Relay should implement this interface called node. And all this node interface does is it guarantees, OK, I have the ID field. And it also guarantees that this ID field has unique ID among all the types inside your API. So not just in your type space for which you are true, but in the whole API. And then you can implement your types with that. And then another important part, you will have the root field, the beginning of your query, that retrieves any object by ID. So any node object. So here you can pass user ID and it will turn you a user. You can pass picture ID and it will turn you a picture. So this way, Relay knows there's this field with which you always retrieve the object by ID. And what it means, let's go back to our stuff. This is still kept as pictures in Relay. But this Relay knows, OK, I have a node root field. That means that if I have something stored as node with some ID in my cache, I can use it. I don't have to retrieve it again. So in this way, you can transition from a list of picture to one picture. Yeah, it's really complicated here because you need to cast the node object to a picture object. But yeah, it just works. So you can say Relay is kind of perfect. I mean, it's not. Because we don't have, we only fetch once because in Relay it stores everything. You can reuse in context, in updates limitation, same way as Apollo. It does data complete the same way as Apollo, and probably it has a small amount of code. But what if we take it further? For example, why do we need to restrict our API so much? Why do we need to force this node interface? Why do we need to force those global IDs? Sometimes they might be inconvenient. Maybe you want to keep the natural-looking IDs. This is totally kind of valid choice of how you structure your API. So maybe we can make node function simpler. Because, I mean, it accepts global ID, and probably inside this global ID, the type name is encoded. So why not just have it explicit and always have node accept type name and ID? This way, your cache can still know that this is the way to retrieve something by ID. But at the same time, you don't have to implement your API in a too specific way. This brings us to future and what next can we do for these caches? Because we now found that restricting your API makes your caches more powerful. And why does it make your cache more powerful? Well, because by restricting your API, you pass this knowledge to the cache. Usually, you are the person who knows your API. You are the person who has information about what kind of data is returned by your API. But by implementing these restrictions, by having this node interface, now this knowledge that you have as a programmer is inside your cache. And same way, we can make cache know more about the API. Because for us, knowing the API is like reading the docs. But for your cache, reading the API is knowing the metadata of the API. For example, how Apollo client knows how to extract the type name with __ type name, and how Relay knows that there is a node field inside your API which it can use to get the object by ID. So, in order to not make it slow, well, __ type name is not slow, but getting the whole introspection of your API might be slow. Maybe you can do this introspection in compile time by having this introspection be queried whenever you compile your application again. So yeah, so the way to make better caches is to have more metadata. And in GraphQL, you can add more metadata by adding these GraphQL annotations. So, for example, maybe we don't want to have a node interface. Maybe we'll just mark that this type user has user by ID as a way of querying it. And now our cache can transition between a list of users and user by ID because it knows that user by ID is the special core, fundamental feature for a user type. We can even not make ID a compulsory field. Like in blogs or in newspapers, often you get your stuff indicated by a slug, which is like this like sort of snake-cased, not snake-cased, spear-cased stuff. So like here we have we indicate that the post can be fetched with post by slug. So now our cache might know, OK, I know that the fetcher for this by slug is this. So every time I go from a list of posts to a post, and the root query is post by slug, I know that I can check the cache and see if I have this data stored by the slug. We can also inverse it. We can inverse it and annotate the fields instead of annotating the types. So this is like exactly the same as this, but inversed. So now we say that, OK, this root field can be used to get the user by ID. We can go deeper. What if we can also make automatic updates for complex mutations? Here we have user list. And usually you have to write manual code in all these libraries, in Apollo, in Relay, to add new stuff when, for example, you paginate. Or add new stuff when you add a new comment to a list of comments when you post the comment, because it's not a trivial thing to implement automatically. But what if we could annotate the fields, or like the fields that are lists, to indicate what kind of mutations perform those list operations on this particular field? And here it's kind of like top-level user field, but maybe we can also have it inside. For example, a picture can have comments, and then add comment would be like an adder or a deleter for this. We can also move the whole mutation definition to server side. If we have a field that removes user, we can mark it like this is like a core deleter for this user. So now every time we call this mutation, your cache can automatically know that like whenever this mutation is called, we have to delete this user from the cache. And yeah, no one does that. I don't know why. Because they're like, we have GraphQL, and GraphQL is so introspective, and there are all the data you can get there, and you can use it to build better libraries. But like even Relay is doing just the bare minimum that you can do. There are so many optimization. There are so many new things we can explore. Like maybe we can compile the cache libraries completely from schemas. So we won't have a normal cache library, but we have like we'll have like an API, like a programmatic interface to work with the cache that will automatically store data in cache when you need it and provide you like type-safe API to get it. And for example, on native, there are Android and iOS Swift code gens that give you this kind of API by compiling the schema. Maybe we can invalidate stuff in our cache by compiling our application side, getting all the queries that we use inside our application, and then seeing which of those queries intersect. And this way, we will have an invalidation graph that will automatically invalidate the data that's affected by certain queries, because we have this graph of query invalidation that we can extract the subset of. So yeah. With GraphQL, we can build smart caches already, and people already build smart caches. And GraphQL can also inspire non-GraphQL APIs to also be more introspectable. And there's stuff like Ember Data where they know a lot about their API, and they can also do lots of smart stuff about it. So it's not just limited to GraphQL. It's just that GraphQL was designed to be introspectable in this way. Because metadata is the key to building better caches. Metadata is the key to building better libraries and to writing less boilerplate code inside your APIs. And yeah, because GraphQL has first-class introspection, that's why I like it. And we should use it more. We should use metadata more. We should use introspection and GraphQL more, and we should build better clients, because then the future would be wonderful. You can find my cats at this Instagram.